Okay, we're going to go over the answer key for the Unit 1 review to prepare you for the test. It says in number 1, okay, we're going to look at number 1. Is F parallel to M? Here's line F, here's line M. The only way we can prove lines are parallel is by angle relationships. The angle relationship, 125 over here is on the outside, 100 is on the outside. These angles are called alternate exterior. And if the lines are parallel, alternate exterior angles would have to be equal. Okay, alternate exterior angles are congruent if the lines are parallel. Okay, are they congruent in this picture? The answer is no. Okay, because alternate exterior angles are not congruent. All right, number 2, given that A and G are parallel and J and W, angle 5 is 85. I'm going to write that in. How much is angle 14? Well, I'm going to fill in all the way around. So this is 85, this is 85, and this is 85. So then I know that the measure of angle 14 is 85 degrees. Okay. Angle 5, I'm going to put this in red, which was given to us. Angle 5 is 85. Angle 14 is 85. They are alternate exterior, so that's going to be our justification. Okay. So alternate exterior angles are congruent. Okay, we always want to write in the picture. It says that angle 1 is 8x plus 52. So I'm going to come over here and write 8x plus 52. And it says angle 4 is 3x plus 40. Now I want to figure out the angle relationship. They're on the same side in their exterior. So the two of those should add up to 180. So 8x plus 52 plus 3x plus 40 should equal 180. I'm going to combine my like terms. I got an 8x and a 3x that comes together for 11x. Then I have 52 and 40, and it comes together for 92 is equal to 180. If I subtract 92 from each side, I get 11x is equal to 88. And if I divide by 11, I get x is equal to 8. Okay, so my justification, if line A is parallel to line G, which is cut by a transversal W, then same side exterior angles are supplementary. All right, that's number 2. For number 3, it's saying that P and M are parallel. They're telling us that angle 4 is 124. And they're telling us that angle 12 is 38. Okay. So I'm going to write in all my 124s. Okay. And I'm going to write in all my 38s. So the next thing I want to do is I want to write in my linear pairs. So I would take 180 and subtract 124, and I get 56. So in a different color, I'm going to put 56. Okay. On the other side, I'm going to take 180 and I'm going to subtract 38 for my linear pairs and find out that my missing angle is 142. Now I can fill in all the given information. I've already filled in the given information. I'm going to fill in the information that's needed. Angle 2 is 38 degrees. B, angle 13 is 142. C, the measure of angle 9 is 142. Angle 10, 124. Angle 11 is 56. And angle 8. Most of my numbers are covered, so let me find angle 8. 56. Number 4, they're giving us that M and T are parallel. So here's M, here's T. Explain why the following statement is false. Use angle pair names and relationships. Let's put in what we know. Angle 5 is 60 degrees. Angle 6 is 60 degrees. So I'm putting that in. All right. Now, I don't see a relationship between the two. So what I'm going to do is use my vertical angles to come up with a relationship. You don't have to do it like this, but I'm going to say that number 5 is 60, so number 8 is 60. Okay? And so angle 6 is 60 degrees, angle 8 is 60. So that means that they are same side interior. And they should be equal to 180, and they don't. So angle 6 plus angle 8 should equal 180, and angle 6 is 60 degrees, angle 8 is 60 degrees, and that does not equal 180. Next, this one can be tricky. Complete the proof. They're telling us that angle 3 and 7 are supplementary. So they're already telling us that angle 3, get my pen working, angle 3 and angle 7 are supplementary. They want us to prove the lines are parallel. So the first thing, 3 and 7 are supplementary. That's given. So we're going with an F for given. Angle 4 and angle 7 are supplementary. If you notice, they're right beside each other. So that's going to be your definition of a linear pair. Now this is where it can get tricky. 3 and 4, students want to call that corresponding, but we need to prove lines are parallel first. And that could be the justification of why they're parallel, not the justification of why angle 3 and angle 4 are congruent. Take a look at this. Here we have angle 7 and angle 7. So if angle 3 is equal to angle 7 and angle 4 is equal to angle 7, then angle 3 is equal to angle 4. Okay? And this is called E, the transitive property. So now that we just proved that 3 and 4 are congruent, those angle relationships are corresponding. So now we can say the lines are parallel because of these corresponding angles. All right, number 6 says, what is the slope of the line parallel? What you need to know about slope and parallel is that parallel lines are going to have the same slope. So first thing we have to do is find the slope of the given line. We want integral points, points that actually cross on the actual vertical and horizontal line. So we're going to go up 1, 2, and over 1, 2, 3. So the slope here is rise over run. And so the slope is 2 over 3. So what would the slope be of a line parallel to that? Well, it would have to be the same, 2 over 3. Now this one has a part 2 to it. It says graph a line that passes through P and is parallel to the given line. All right, so we're going to go with some green. We have to go through P right here, and we need the same slope. So we need to go up 2 and over 3. 1, 2, 3. Here we go. And then we can go down 2 over 1, 2, 3. Down 2 over 1, 2, 3. And just connect those. And we have a line parallel. Okay. All right, this one, the vocabulary is slightly different. This is how we check to see if you have an understanding of the material. This is perpendicular. So perpendicular, we still need to find the slope. So I'm gonna pick a point here and a point here. I wanna go up 1, 2, and over 1, 2, 3. So my slope, rise up 2, go back 3. So my slope is negative 2 over 3, or some may say 2 over negative 3. Now the second part says graph a line perpendicular going through P. Well, if my first slope is negative 2 over 3, then my perpendicular slope is negative reciprocal. First one is negative, so this one needs to be positive, and this will be 3 over 2. So from P, I'm going to use the slope 3 over 2. So here's me at P, going up 3 over 2. Up 3 over 2. And I'm going to connect those. And even though it's not the straightest line, guess what? It connects to make a 90-degree angle, which is what perpendicular is. Okay. Number 10, it says we need a sketch. So line CD. So we're going to do line CD. You just make a line and you put those 2 points on there. Perpendicular to EF. Perpendicular means a 90-degree angle, so we can just get our box in here. The intersection, we are going to call this T. So CTE, which is from C to T to E, is 4x plus 30. So that means 4x plus 30 is equal to 90. Subtract 30 on each side, and 4x is equal to 60. Divide by 4, and x is equal to 15. Number 10. Number 11, SR. GP. Perpendicular means 90. Point in the middle is V. R to V to P is 8x minus 70. So 8x minus 70 is equal to 90. 8x is equal to 160, and x is equal to 20. Number 11. Number 12, determine the relationship between the original and the new. Let me tell you how I do these. I look at the original. The pool does not have enough chlorine in it, and I call it P. Pool members cannot go swimming. I call it Q. Now I want to compare my original statement, my new statement, to my original statement. It says the pool does have enough chlorine. So I went from the pool does not have enough to the pool does have enough. So in order to get that, I had to negate my statement. So my P should have a negation in front of it. Then the pool members can go swimming. Pool members can now go swimming. So I'm going to negate Q because it says everything that Q says except it's the opposite. So my symbols are negate P, arrow, negate Q. So is it converse, inverse, or contrapositive? Well, when you just change the negation, it is inverse. 13 says the remote control is not working. The television will turn on. Here's my statement here. P, the remote control is not working. Q, the television will turn on. So use the above to complete the boxes below. So the remote control is working. Okay, so we went from it's not working. We went from not working to working. How did our P change? It was negated. Then the television will turn on. How does that compare to our first statement? Okay. So we put that in. So we had a negate P, an arrow because we heard the words if, then, and then a Q. All right, we're going to match each term to the symbolic form here. Conditional is P, arrow, Q. And what type of statement is that? It's an if, then, Q statement. Converse is going to be Q, arrow, P. Just change the order. So we'll say reverse. Reverse the conditional. Inverse is going to be your negate P, arrow, negate Q. So this is a negate. Contrapositive is going to be your not Q, arrow, not P. So what are you doing here? We're reversing and negating. Okay, so when we look at this statement here, we notice that if and only if is in the middle. We have an if here, and we have an if here, so it's two of them. So this statement is called a biconditional. So the symbolic form for biconditional is P, double arrow Q. For this statement to be true, what must be true? The conditional must be true, and the converse must be true. If you can get the conditional and the converse to be true, then you have a biconditional statement. Okay, we're going to do this last one because 17, we're not doing that. We didn't study Venn diagrams. So which of the following conditional statements can be written as a valid true biconditional? Let's look at number 1. If you live in Virginia, then you live in the United States. Okay, I like it. Now let's switch it around. We'll put it in blue to do a switch around. Want to start in blue. If you live in the United States, then you live in Virginia? Nope, false. So that's not a good statement, right? Let's take a look at the next one. If two angles are vertical, then the angles are congruent. True. Let's switch it around. If the angles are congruent, then the angles are vertical. Nice. So if you play football and you're an athlete, that sounds good. But if you are an athlete, you have to play football? Nope. If an angle is a right angle, then the angle measures 90 degrees. Okay, and if an angle measures 90 degrees, then the angle is a right angle. Oh, wait a minute. So now we're going to need to double back and see if our B statement is actually true. So let me go ahead and erase so we can go over this again. Here we go. If two angles are vertical, true, then the angles are congruent, true. Now let's switch it around, give it some red. If the angles are congruent, do they have to be vertical? No, so that would not make a true biconditional statement. So the answer is D. Hopefully this helped you with the review. Thank you for tuning in.